Hi! So far I didn't have a good way of cutting box joints or tenons, so recently I built myself this box joint jig for my homemade table saw. This jig can handle workpieces that are up to 500 millimeters wide, and it can cut tenons that are up to 70 millimeters long. This jig consists of a carriage that's holding the workpiece, a base that provides all the support and contains all the guts, and a power supply. This carriage just slides on a wooden rail and it gets pushed around by this ball screw that is turned by a stepper motor. The stepper motor gets driven by a stepper driver down here, which is controlled by an Arduino Nano, just like this one. And then I do only have my limit switch in here and another limit switch in here. And then of course my two control buttons. This one is for advancing the carriage and this one is for homing the carriage. And that's really all there's to it. The computer-controlled box joint jig is of course not a new idea, but what I really like about it is that it can quickly adapt to any size of joint and any size of blade that I want to. Also, it makes for a very quick and very safe process that is basically almost impossible to screw up. This jig in particular will always produce a perfect result, and I'm gonna explain how that works a little bit later. And coming up with the code and then seeing the thing actually working was really a lot of fun. So these are the power supplies. 230 volts AC are fed in through this wire, then they get converted to 30 volts DC for the stepper motor and 5 volts DC for the Arduino, and then this is connected to the jig with those two wires. Of course I thought about adding a display and a numeric pad, but for now plugging it into my shop computer is convenient enough. And I'm definitely not gonna make an app for it. So all we need to do is to enter the desired thickness of the fingers and also the width of the saw curve and upload. And the computer will automatically calculate all the increments and how many hogging cuts it has to make. Okay, let's make a box joint. I'm gonna use this piece of MDF as a backer board, and here are my two pieces. And they need to be offset by the width of a finger. And I'm gonna line everything up with the curve on the jig and clamp it in place. The sides of the fingers are cut first to avoid the blade getting deflected by only partially cutting on its edge. Then the jig goes in reverse and hogs out all the material. These hogging cuts overlap a little bit, which creates a very clean bottom between the fingers. And I can even give you a close-up. So this jig allows me to cut extremely precise joints. However, I found that a fine box joint just can't be cut to the same kind of tolerances as a coarser box joint, because the fine box joint with a lot of surface area just can't be assembled with glue on it if it's cut to the same kind of tightness as the coarse box joint. So my solution to this was to make the jig adjust the tightness of the joints by subtracting different very small increments from the value of the width of the curve for different sizes of fingers. And that works because the smaller the value that the computer uses for the width of the curve in respect to the real width of the curve, the wider will be the space between the fingers and the narrower will be the fingers themselves, if that made any sense. So what it boils down to is the jig will always produce the perfect kind of tightness for every joint, without me even thinking about it. Let's make a finer one. All I need to do is to change the width of the fingers from, in this case, 10 millimeters to, let's say, 5 millimeters. And here we go. Something that I should have thought of when I wrote the program is some way of manually adjusting the carriage a little bit, let's say using a potentiometer, because lining up the workpiece with the blade is tricky and sometimes I don't get it quite right and then end up with kind of an additional super thin finger, which is not a big deal. I can just snap it off and continue, but it would be nicer not having to do that. And that's what it looked like after sanding. Some people like to point out how electronics aren't gonna last forever, which is true, but I think that this system is gonna work for years and years and years to come. Probably not forever. Isn't dust gonna ruin that ball screw? Honestly, I don't know. It seems like it wipes itself clean every time, but I don't know how long that's gonna work. If this ball screw should get stuck or whatever might happen, I'm gonna replace it with an Acme spindle. And yes, you could use just a regular threaded rod. I was really concerned with the motor skipping steps and ruining the accuracy, because this is an open-looped system without any positional feedback to the microcontroller, but I tested it over the entire length of travel of the carriage with a lot of weight attached to the carriage, and apparently it doesn't skip steps at all. Phew! Okay, that was my computer-controlled box joint jig. I hope you found this interesting and liked the video, and till next time, when I meet you with a box joint project. Oh, and before I forget, how much did it cost? Well, I don't know exactly because I had all the stuff basically lying around, but the electronics components cost about 200 euros maybe, and about 80 of those alone is the ball screw. So if you substitute that with a piece of threaded rod, you can get away much cheaper.